Recall that that rational equations are equations where we have fractions, and specifically when we have a variable in the denominator of a fraction. In all of these cases, remember that any time that we dealt with a rational equation, our favorite step one is to get rid of the fraction. And in order to do that, what we want to do is to multiply by anything that would be in a denominator, get those denominators to cancel out, and then have a new equivalent equation that doesn't have any fractions in it. This was a great process. We really loved it. However, when you do this process, sometimes it ends up introducing equations that are quadratic in nature. And now that we know how to solve quadratic equations, we're going to go ahead and get some practice on solving rational equations where we get some quadratic fallout. Let's take a look at an example of where this might happen. In problem number 5, notice that we have an equation with fractions in it. Especially because there's an x in the denominator, that's a real problem. So what we want to do is we want to very cleverly, and I'm just going to go ahead and copy the problem here so we don't cross our original thing out very well here. In this particular problem, here's my equation. Because x is in the denominator, I need to multiply both sides of the equation completely by x. What that means is I'm going to have to distribute and multiply each term by x. So I'm going to times this first piece by x, I'm going to times this piece by x, and I'm also going to times this piece by x. Now let's see what happens. In the first equation, the sole purpose of multiplying by x was to cancel out that denominator, so all that leaves me with is a 6. In the second in the second term here, I had an x there before, but because there was no denominator across the x outside with, I'm left with x times x, which is x squared. And in the last example, again, there was no fraction to cancel out the x, so I have to still multiply that by this final term here, and x times 12 gives me 12x. So in the process of getting the x out of the denominator, which I had to do, I came up with a new equation, and this new equation has an x squared in it and also has a plain x in it, and I don't really like that. Because I can't just work to get the x by itself. However, recall that anytime you have a squared and a plain x, it's a quadratic equation, and we can solve quadratic equations by getting one side equal to 0 and then either factoring or using the quadratic formula. In this case, I am going to go ahead and add x squared over to the right. I like my squared terms to be positive. It makes me feel better. I'm also going to minus 6 from each side. And that gives me a 0 on the left, and on the right, when I write my terms in descending order, I have a positive x squared, a plus 12x, and a minus 6. Now, if you try to factor this, you're going to quickly find that it's not going to work. With 6 and 1 as my factors, or 2 and 3 as my factors, there's no way I can end up at 12. So I'd like to try using the quadratic formula to solve this instead. So we're going to let a equal 1, my value in from the x squared, b equal 12, and c equals a negative 6. Going into the quadratic formula, again, negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's plug our numbers in. Negative b was 12 plus or minus the square root of 12 squared minus 4 times 1 times negative 6, 4ac from that. And we're going to divide the whole thing by 2a, or 2 times 1. Go ahead and treat each of these little pieces as individual sections here. We're going to have negative 12 plus or minus the square root of, let's see, what do we get when we do this? 144. This is going to be plus 24. 144 plus 24 gives me 168, square root of 168, all divided by 2. In this particular case then, if you want to simplify your expression to get your two possible solutions in this case, we can in fact go through and see if there's any perfect squares in here. It is even. 84, 2 goes into that also. 42 times, that's 6 times 7, and 2 times 3. So we do have a set of 2's that are in there. So we can write this as x equals negative 12 plus or minus the square root of, so this is square root of 4 times the square root of 42. So we can write that as 2 square root of 42 when we simplify over 2. We can break each of these pieces up. I'm going to go ahead and erase this so we have a little bit of space here. And now we can divide each of these. So negative 12 over 2 plus or minus 2 radical 42 over 2. And then we can simplify and get our final solutions here. -6 plus or minus the square root of 42. You could also evaluate that on your calculator to get two different solutions in decimal form for what these pieces and values would be. But we do in fact get two different answers here for my solutions. I guess we can pull this up here real quick if you want to compare that with a decimal value if you were following along on your calculator. -6 plus the square root of 42 would give me 0.401 as one solution, and then -6 minus the square root of 42 would give me a -12.5 as my other solution. And with decimal or with values like this, as long as our answers wouldn't make the original denominator 0, we're good to go. Okay, let's pop up here and take a look at another example. So that's just kind of one way. As you try to solve an equation, sometimes in the process of getting rid of the x's, we end up with x squareds in our equation that we then need to solve. Okay, so let's take a look here. In this problem, I have a 9, a 6, and a 2. So if I want to multiply by something that's going to get rid of all of these fractional denominators, I need something that will go into all of those values. Let's see. 9 doesn't work. 18. Looks like 18 should work. That looks good. So let's go ahead, and what we're going to need to do is multiply each term by 18. We're also going to need to multiply each term by x, because there was an x in the denominator here. So multiplying each of these terms by 18x is going to help us to get rid of the fractions completely so that we can have one equation where everything is on the main level. In this problem, the x's are going to cancel out, top and bottom here, and the 9 is going to reduce with the 18 and get us down to 2. So I'm left with 2 times 5, which is 10, for multiplying by 18x in my first fraction. In my second fraction, again, I have an x that I'm multiplying by that'll cancel out with the x in the denominator. There's a 6, and 6 will go into 18 3 times, and then I can multiply the 3 times the 2 that was left, and I end up with plus 6. In the last example here, I have a 2 that's going to cancel out with the 18 and get me down to 9. There's still an x here. So what I have here is 9x times 3x, which is going to give me 27x squared. So again, the 2 and the 18 get me down to 9. The x is still there, and when I multiply that all out, I get 27x squared. Now, on the right-hand side, 10 plus 6 is 16. That was pretty good. And on the right side, I have 27x squared. Now, in this problem, this is actually a really cool one. Notice that we have an x squared. That's fine, but there's no plain x term. So this means that we can solve just using our regular traditional methods for getting the x alone, just by undoing order of operations. We really only have to use the quadratic formula when we're put into a position where we have to deal with having both an x squared and an x in the same equation, which is not the case here. All right, so how do we go on from here? I want to get the x by itself. It's being times by 27, so we're going to divide by 27 on each side. It's a fraction that doesn't reduce, and then I'm going to deal with, and then I have x squared. And so to finish solving, to get rid of an x squared, I take the square root of each side. Remember, when you take the square root of each side, you introduce the possibility of two answers. So I'm going to get plus and minus here on the right, on the left. On the right side, the square and the square root undo just to leave x. Now what I have to do is I have to figure out what the square root of 16/27 is. Well, we can take the square root of the top and the bottom. On the top, the square root of 16 is 4. It's a nice perfect square. And on the bottom, I have the square root of 27. Now, we have two problems with this solution. So we've got two answers. But I do have two problems with this solution. One is that 27 is not a perfect square, and the other is that I have a radical in the denominator. So we need to deal with both of those problems. Which order you deal with those in is totally up to you. Let's go ahead. 27, of course, is 3 times 3 times 3. So we got a pair of 3's there. Square root of 9 times square root of 3. Square root of 9 is 3. So the square root of 27 we can write as 3 root 3. Since there's no pluses or minuses on the bottom, I can get rid of the denominator radical by just multiplying by another square root of 3 to get things to work out nicely. In that case, 4 times square root of 3 is just 4 square root of 3. On the bottom, we do insides with insides and outsides with outsides. So I end up with 3 square root of 9. Square root of 9 is a perfect square. It's just 3. And then I can do 3 times 3 because they're both on the outside. Don't forget, again, that we had both a plus and a minus in this particular case from when we took the square root of each side. And with a squared in my equation, I should be expecting 2 different answers in my solutions. So that would be the most simplified square root version solution for my original equation. All right, let's try a couple of other examples here and see how these will work. In this next problem, again, we've got fractions. We don't like them. We have an x minus 3 in the denominator of one. We have an x plus 2 in the denominator of the other, and then we have no denominator in the last one. So we're going to need to multiply by things cleverly in order to get things to cancel out. So in this case, I'm going to need to multiply by x minus 3 to get rid of this denominator, but I'm also going to need to multiply by x plus 2 to get rid of the next denominator. So that's what I need to multiply each of these things by. Oops. An x minus 3 and an x plus 2. And then I also have to multiply this by an x minus 3 and an x plus 2. Okay, so let's see what happens here. And the first fraction, my x minus 3's cancel out, and I'm left with 5 times x plus 2. Anytime that you're multiplying by something where there's a plus or a minus in it, always use parentheses so you can remember to distribute things appropriately. When I get to the next one here, the x plus 2's are going to cancel out nicely. I'm still left with an x plus, or an x minus 3 as well as the x that's there. I'm going to write the x in front because that's how I'm used to seeing things with the distributive property. With if there's a single value, we write it in front of the parentheses. On the far side here, there's nothing to cancel out, so I'm going to have to do all of these things. 5 times x minus 3 times x plus 2. Okay, so there's my equation I need to solve. Lots of x's, lots of parentheses. What I'm going to have to do before I'm done. First thing I would do is distribute. So here I'm going to multiply that through. 5x times is going to be 5x. Sorry, 5 times x is 5x plus 5 times 2 is 10. For the next one, x times x is x squared minus 3 times x is so minus 3x. On the right hand side, notice that I've got 3 groups of things being multiplied. Remember, you multiply things from left to right. So I'm going to multiply 5 times x minus 3, so I'm going to have to distribute that through. 5 times x is 5x, and 5 times minus 3 gives me a minus 15. So that does my first 2 multiplications. And then I still have to multiply that answer by x plus 2. So I'm going to have to use FOIL this time because I have stuff in parentheses being multiplied by something else. While I'm on a roll, I'm just going to go ahead and do this right-hand side here. 5x times x gives me 5x squared. On the outsides, 5x times 2 gives me plus 10x. On the insides, I get a minus 15x. And from multiplying my last terms, negative 15 times 2 gives me a minus 30. I'm just going to go ahead and copy all this stuff over here from the left. All right, looking pretty crazy, but now we at least have no parentheses and everything's been multiplied out. At this point in time, I highly recommend going ahead and combining like terms, making each side so that my highest power term is on the left. So here I'm going to have x squared. I can put the 5x and the minus 3x together to get a plus 2x. And then my number value gives me a plus 10 on the left. On the right-hand side, the 5x squared is my highest term value there. I've got a pair of middle terms I can combine to get a minus 5x, and then I still have a minus 30 left on the right-hand side. Okay, so far so good. I still have x squareds in this problem. I still have plain x's in this problem. So I'm going to need to use a quadratic formula or a quadratic equation process to solve. That means I need one side of my equation equal to 0. I'm going to move everything on the left over to the right-hand side because that's going to make my x squared term be positive. So I'm going to minus x squared from each side. I'm going to minus 2x from each side, and I'm going to minus 10 from each side. On the left, that has the effect of the x squareds canceling, the 2x is going out, and that plus 10 minus 10 going out and leaving me just with 0. On the right-hand side, 5x squared minus x squared is 4x squared. Negative 5x and negative 2x gives me a minus 7x, and negative 30 and negative 10 gives me a negative 40. No greatest common factor terms or anything like that that I can pull out. So again, I dive into the quadratic equation unless you see some factoring that will work quickly for you here. A is 4, B is -7, C is -40, and we can go in and use the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Plugging our numbers in, we get -7 plus or minus the square root of -7 squared minus 4 times -40. And I'm going to divide the whole thing by 2 times 4. All right, we'll keep scrolling down here as we go. These problems do get kind of long. The -7 gives me a +7. Simplifying inside the square root here, I'm going to go ahead and let the calculator do that one for me here. Oh, go over there. There you go. Okay, so here I have -7 squared. Make sure you use parentheses for that. Minus 4 times 4 times -40. Gives me 689 inside my square root. I'm going to divide that whole thing by 8. All right, and then for this problem you can try to simplify your square root values if you can. Let's go through and try a few things. Let's see if 689 has it seems like kind of a weird number. If there's anything that goes into it, pretty sure 3 won't go into it. No, 689. Some common ones are maybe 7. No. 11. No. 13. Ah, okay, so it's 13 times 53. That actually isn't prime. However, 53 is prime, so there's no pair factors in that one. Interesting. Okay, so we can go ahead and get that particular solution, or 2 solutions, right? Because we get one from a plus and one from a minus. And we can evaluate that and find the decimal approximations if that's the form that your answer should be in, or you can just consider that a simplified square root problem and leave it looking like that. If you decide to break it up, remember we talked about that a little bit. The 7 would get divided by 8. We would consider that 1/8 times the square root of 689, or just the square root of 69 over 8, like that. So either of those forms is good for that particular solution. All right, one last example here before we continue on. In this particular problem, notice that we have a lot of denominators. We have an x minus 5 and we have an x plus 7 here. But I also have this x squared plus 2x minus 35. And when I look at this, I'm kind of worried, because if I multiply by all of these, I'm going to have some really crazy multiplications that show up in this particular problem. However, let's go ahead and take a second and factor what we have in this denominator, because it actually factors really nicely. Here, x times x will get us the x squared. To get 35, we can do 7 and 5. And with a plus 7 and a minus 5, we end up getting the positive 2 in the middle that we need. Now notice that what this means, I needed to multiply by x minus 5 for this one, and I needed to multiply by x plus 7 for this one. So awesome. By multiplying just by x minus 5 and x plus 7, I'll be able to take care of the denominators for all 3 of these without having to do this whole crazy thing as a factor as well. Okay, so let's write out what this is going to look like. So I have 3x minus 1 over x minus 5 minus 2x plus 1 over, I'll just write it in factored form here, x plus 7, x minus 5 equals 3 times x plus 7, or 3 over x plus 7. All right, so I'm going to multiply everything by x plus 7 times x minus 5. This term. And this term. So you got to do it by all 3 of them. Now, first thing you want to do is completely get rid of denominators. So here the x minus 5s go away, and I'm left with x plus 7 times 3x minus 1. That here. Be sure to put those things in parentheses as you go, because we're going to have to deal with that. When we get to the next one, I had an x plus 7 will cancel with the x plus 7, the x minus 5 with the x minus 5. The denominators are gone. There's nothing to multiply through. However, keep in mind that this subtraction was for the whole fraction, so be sure to put minus the 2x plus 1 in parentheses there, so the subtraction gets distributed through the whole fraction. And in the last part, we had an x plus 7. That part's going to cancel out with this x plus 7, and what I'm left with is just 3 times x minus 5. Okay, so new equation, no denominators. That's awesome. Lots of x's and lots of parentheses. So we're going to do the same thing we did before, FOIL everything out, and collect like terms and see what we can do. So for the first group, because I have a binomial times a binomial, I'm going to have to use FOIL. So do that whole thing. So x times 3x gives me a 3x squared. X times a minus 1 gives me a minus x. 7 times 3x gives me plus 21x. And 7 times minus 1 gives me a minus 7. Going on to the next set of terms here, I had a minus outside. You can think of it as a negative 1 being multiplied through if you want. It has the effect of changing all the signs inside, so that'll be a minus 2x and then a minus 1. On the right side, I just had a 3 that's being multiplied by the x minus 5, so be sure to distribute that, and we end up with 3x minus 15. All right, so far so good. Now the last piece that I'm going to need to do as part of this problem is get one side equal to 0. I've got x squareds and x's, so a lot of work to do here. I'm going to start just by simplifying the left-hand side. So here I have a 3x squared. Then I have quite a few x terms here I can put together. Negative x plus 21x is 20x, and then minus 2x is a positive 18x. And then I have a minus 7 and a minus 1 that gives me minus 8. On the right-hand side, I have 3x minus 15. Okay. Again, x squareds and x's, so I need one side equal to 0. So this time I'm going to move everything over to the left since the 3x squared is positive where it is. So I'm going to minus 3x from each side. I'm going to plus 15 from each side. Everything on the right-hand side is going to cancel out and leave me with the 0 that I need. And on this side, I have 3x squared plus 15x, and then negative 8 plus 15 gives me a plus 7. All right, so at this point then, what I need to do is I need to try to either factor this equation here, which I don't think will work, or alternatively, I need to use the quadratic formula. So my a is 3, b is 15, and c is 7. Again, quadratic formula is right here for your reference. So x is equal to negative b, negative 15, plus or minus the square root of 15 squared, minus 4 times a is 3 times c is 7, all divided by 2 times a, which was 3. Simplify each group. So the negative b part in front gives me a negative 15. Inside the square root, I've got all sorts of fun stuff there, so I'll pull my calculator up to help me out. Okay, let's see what we get here. 15 squared minus 4 times 3 times 7 is 141. Inside the square root, and then on the bottom 2 times 3 is 6. Again, it's not a bad idea to double check to see if there's any factors of 100 or anything that goes into 141 evenly. I think 3 actually will go into that evenly. So 141 breaks up to 3 times, I forgot already, 47. But I don't think that 47 has any factors. I think 47 is prime. So as we go through here, that's as simplified as we can get. You can just leave your answer like that, or if you like breaking it up, we can write that as negative 15, 6 plus or minus radical 141 over 6. Or if the question asked, you could get those two solutions by evaluating the radicals with your calculator and getting approximate decimal solutions instead. But either way, again, our processes for solving these rational equations by multiplying by something clever to get rid of the denominator totally still apply. But when you do that, if you're left with both squared and x terms, then it's going to be your job to use the quadratic equation or to treat those quadratic equations and solve them by using either factoring or the quadratic formula, like we did in these examples. Go ahead and try a few on your own from the homework.